Pelton turbine. Construction and working. A Pelton turbine is a type of impulse turbine primarily used in hydropower plants to convert the kinetic energy of high-pressure water into mechanical energy. It is especially suited for high-head, low-flow applications, such as mountainous regions where water falls from a significant height. 1. Construction of a Pelton turbine. The Pelton turbine has several key components that work together to extract energy from the water. Here are the main parts. Runner. 1. The runner is a wheel with paddles or buckets that are shaped to catch and deflect water jets. The runner is mounted on a shaft and rotates when water strikes the buckets. The shape of the buckets is crucial for the turbine's efficiency. Each bucket is split into two parts, called buckets, and dividers, that help split the water jet and redirect it in the opposite direction. Buckets. 2. The buckets, usually made of steel or other durable materials, are positioned around the circumference of the runner. Each bucket is designed to change the direction of the water jet in such a way that the impact results in the maximum possible conversion of kinetic energy into mechanical energy. Water nozzle. 3. The nozzle is a key component that directs the water flow from the penstock, water pipeline, into the turbine. The nozzle can be adjusted to control the flow rate of water and ensure that the water strikes the turbine's buckets at the correct angle. Penstock. 4. The penstock is a large pipe that transports water from the reservoir to the turbine at high pressure. The pressure from the height difference between the water source and the turbine's position is the primary driving force. Jet. 5. The jet of water is emitted from the nozzle, and it strikes the runner's buckets with a high velocity. Shaft. 6. The shaft is connected to the runner. It transfers the mechanical energy generated by the turbine to the generator or other mechanical devices. Casing. 7. The casing is the outer enclosure that surrounds the turbine assembly, typically designed to protect the turbine from external elements and to maintain the appropriate alignment of parts. Bearing and shaft support. 8. Bearings are used to support the shaft and allow it to rotate smoothly while maintaining the alignment of the turbine's moving parts. 2. Working principle of the Pelton turbine. The Pelton turbine operates on the impulse principle, where the water jet's kinetic energy is converted into mechanical energy. Here's how it works step by step. High-pressure water flow. 1. Water from the reservoir flows under high pressure through the penstock and reaches the nozzle. The pressure is a result of the height difference, head, between the water source and the turbine. Water is directed through the nozzle. 2. The nozzle directs the high-speed water jet at the buckets on the runner. The nozzle is adjustable to control the flow rate of water to the turbine. Jet strikes the buckets. 3. The jet of water strikes the buckets tangentially. Each bucket is shaped to split the jet into two parts. When the water strikes and flows along the curved surface of the bucket, it changes direction by 180 degrees. Impulse energy transfer. 4. The impact of the water jet on the buckets causes the runner to rotate. The turbine's impulse comes from the velocity of the water jet, not from its pressure. The water's kinetic energy is transferred to the runner through the impact, causing the runner to rotate. Rotation of runner. 5. As the water changes direction, bounces off the buckets, the runner turns. This rotational movement is transferred to the turbine's shaft, which is connected to a generator or mechanical equipment for further energy conversion. Exhaust water. 6. After striking the buckets, the water exits at a low velocity and is discharged into the tail race, the waterway that carries the water back to the river or reservoir. Advantages of Pelton turbines. High efficiency. Pelton turbines are highly efficient in high-head applications. Adaptability. They can handle large variations in flow rates. Durability. They are robust and can operate in extreme conditions. Applications. Pelton turbines are best suited for high-head, large vertical drop, and low-flow water conditions, such as mountainous or hilly terrain. commonly found in hydroelectric power plants, particularly where water is available at high pressure and low flow rates.